Binary. Multiplying binary numbers. Right, the first trick to learn is that anytime you want to multiply a binary number by 2, simply add a 0. This is the same with our normal decimal base numbers. For example, 25 times 10, we know that all we need to do is add a 0. So 25 times 10 equals 250. So that's the first trick to remember. Binary, multiplying by 2, add a 0. Same with decimal. 25 times 10 equals 250. Hexadecimal is exactly the same. Hexadecimal, let's try AD times 16. Okay, so any number times the base is that number with a 0 on the end. So let's look at our binary example. So 0, 1, 0, 1. If I want to multiply that by 2, so times 2, we just go 0, 1, 0, 1, 0. Any binary base, multiply by 2, add a 0. Alright, let's move that to the side. Yeah, what about binary? Multiplying 4 by 3. Okay, let's change that around, sorry. This one's now 4. That's binary for 4, that's my 3. Cast your minds back to working out how that is 3. That's 1, that's 2. 1 and 2 is 3, or 1 times 2 is 3. And look at this one, 1, 2, and 4. Okay, let's work this out. Here we go. 1 times 0 is 0. 1 times 0 is 0. It's the same as what we'd normally do. 1 times 1 is 1. And 1 times 0 is 0. And we do exactly the same. We do exactly the same with this one. The result is going to be the same, but just like when we do decimal multiplication, we add a 0. So we do the same in binary. We start off with a 0, and it's going to be 0, 0, whoop, difficult with this tool, and 1, 0. Okay, and now we simply add them together, so we end up with 0, 0, 1, 1, 0. So that's 0, 0. Whoops. It's 0, 0, 1, 1, and 0. Wow, not terribly neat, but you get the idea. Okay, is this any different to what you've done with decimal numbers? When we multiply decimal numbers, no, it's no different. And you can check out if your answer is correct. Remember, when we are converting binary to decimal, we use the 1, 2, 4, 8, and so on exponential scale, and you will see that this 1 falls under the 4 and that 1 falls under the 8. Let me try and explain it like this. Brush color. Right, so that 0 is 1, that 0 is 2, they count for nothing. This is our exponential scale that we use to convert binary to decimal. There we go, 4, and that falls under 8. And 8 plus 4 is 12. What is 3 times 4? 3 times 4 is 12. So this binary number, 0, 1, 1, 0, is 12. And we could go check that out. We could double check our answer by typing that into an online site that converts for us. But the idea is to get the multiplication going, to get that right. Not terribly different to what you are used to already. Right, left out a 0 there, but you get the idea. 0, 0, 1, 1, 0 is 12. How did we work that out? By multiplying binary 3 by binary 4. and we did it in much the same way as we do our decimal multiplication. Right, let's move that out the way, and let's have the number 3 times 5. We'll use 3, and now we're going to have 5, binary for 5. And by the way, these smaller numbers come up so frequently, you'll get used to them. Alright, what is 5? Well, it's 4. There's our placeholder, exponential placeholder, and there's 1. So we know that that's 5. Okay, and you say, well, what do I mean exponential placeholder? Well, once again, it's the 1, 2, 4, 8, and so on. Let's see what happens here now. I'm going to make it a little bit slightly more difficult and make it 11. All right, 5 times 11. That's 1011. All right, let's see what we're going to be doing here. Well, 1 times 1 is 1. 1 times 0 is 0. Getting a little bit better at that. 0. 1 times 1 is 1. And 1 times 0 is 0. Now, let's have a look at the next binary digit down. But I wonder if you've noticed the knack, the trick. Do you see, because it's 1 times the whole top row, it's going to be a repeat of that exact binary number. We're basically saying 1 multiplied by the binary of 5 is binary 5. Watch what happens here next. And it's going to be exactly the same for the next, because we've got another 1. So it's going to be 1 multiply binary 5 by 1. It's going to be exactly the same, except we shift 1 down. We shift 1 down. So let's see, let's have a look at that. We're going to do it in a different color, and it's going to be 0, 1, 0, 1, and we shift down 1 and put in a 0. Well, what happens with the next one? Let's just try a different color again. We've got 0 times 1, 0 times 0, 0 times 1, 0 times 0. Nothing happens there. They're all zeros. There we go. If you like, put in a whole lot of zeros, but you don't need to. You don't need to do that at all. So we can ignore that and go straight to our final digit of 1. Let's try that one out. Here we go. Once again, it's a repeat of the entire top line. Now, with multiplying binaries, this is the trick to learn, because this will come up time and time again, and it's extremely easy. In fact, it is easier than adding binary, because when you're multiplying one, or a whole binary row, sequence of zeros and ones by 1, it's exactly a repeat, except because we've gone 1, 2, 3, 4 down the line, there are 4 zeros to put. Well, actually 3 zeros to put. We don't put 1 there, but 1, 2, 3, 3 zeros to put down. 1, 2, 3, and now, whoopsie, 1, 2, 3, 1, 2, 3, except, and now it's just a repeat of that entire top line again. So 0, 1, 0, 1, 0, 0, 0. So we got 0, 1, 0, 1, 0, 0, 0. And sorry, that should be like that. Now we can add them together. Right, so now we can just add it up, as we know how to do. There we go, that's 1. That's 1. That's 1. That's 0, carry 1, which is 1. 1 and 0. So what have we got? We call this adding up by dropping our ones down, and we carry a 1 when there are 2 ones, just to remind you of how to add binary. So let's have a look. We're going to bring in our binary placeholder table, and we're going to say, right, that's 1, 1, 1, 0, 1, 1, 0. So we've got 32. So very quickly, let's keep 32 there. We know we've got a binary digit, a number 1, representing 32. We've got another one representing 16. And we've got 7. Why have we got 7? We've got 4, 2, and 1. So we've got 55. Let me see, 55. Yep, 55. That's exactly right. And 5 times 11 is 55. So we can double check. I'm going to show you just one more example. But that'll be part 2. That's all for now. And that was multiplying binary numbers.